Okay. Bailey, what question did you just ask me? This is an easy lesson, all right? This is a very, very, very easy lesson if you will simply write down proportions, all right? So, every time today, you are going to use a proportion to solve it. Now, look at our problem. It says a statue casts a shadow 30 feet long. At the same time, a person who is 5 feet tall casts a shadow that's 6 feet long. How tall is the statue? So, this statue right here, I don't know the height of it, but I know that its shadow is 30 feet long. At the same time, somebody who's 5 feet tall has a 6-foot shadow. All right? Now, there's lots of different ways that we can set up this proportion. Here's how I'm going to do it. I'm always going to use this first one first, okay? And since shadows are on the ground, anytime we have a shadow, I'm going to put it on the bottom. All right? It doesn't have to be like that, but this is just always how I'm going to do it. So, my first ratio is going to be h feet over 30 feet. Again, I'm going to choose to keep my shadows on the bottom. Carry your units across. Now, over here, I've got the same thing. Person's 5 feet tall, 6-foot shadow. So I'm going to put those numbers in. Again, I'm going to put 6-foot shadow on the bottom. So, that's my proportion. That's all there is to it. H over 30 equals 5 over 6. So, solve that. 30 times 5 divided by 6 is what, Jamie? 25. This statue is 25 feet tall. Yes?
Like for the age, the proportion, can you just like leave a blank?
Sure. Yep, that's fine. All right. Number 2. A building casts a shadow 72 meters long. At the same time, a parking meter that's 1.2 meters tall casts a shadow that's 0.8 meters long. How tall is the building? Set up a proportion. Keep your numbers together that go together, and keep your shadows on the bottom. Figure out the height of that building. What is the height of that building? Okay, Bryce, what is my first ratio going to be? H over 72. Very good. These two go together. So this is going to be my first ratio. H meters over 72 meters. Bring your units across. All right, again, keep the shadow on the bottom. So Abby, what is my ratio going to be over here? Very good. 1.2 over 0.8. That's how we set up a proportion. So then we just solve it. Bryce, what was that answer? 108 meters. It's 108 meters tall. By the way, this is the way that we're going to measure the school tomorrow. All right? This is how we're going to measure the school tomorrow. Okay, number 3, surveying. The two triangles shown in the figure are similar. Find the distance D across the Red River. Okay, here's the thing. You're a surveyor. You need to know the distance across the river so that you can build a bridge. Are you going to take a tape measure and swim across the river to the other side and measure it? No, let's figure out a better way. So, we're going to set up a proportion again. Once again, use the two numbers that go together. It should be very easy to see on this triangle that 1 and 0.9 go together. 1 kilometer, 0.9 kilometers. Carry your units across. Now, I've only got one example like this. Actually, I've got two examples like this, but you're only going to see one right now. Okay? So pay attention, don't miss it. You got one shot. All right? Everybody watching? You see how this is a straight line right here? That means these two numbers, 1 and D, are on the same line. So over here, 1 and D have to be on the same line also. All right? We're saying it again. Up here, 1 and D are on the same line. So over here, 1 and D have to be on the same line. So this is going to be D. And then my other number is 1.8. How many kilometers across is the Red River? Serena, how many kilometers across is it? 2. It is 2 kilometers across. All right. Now this one, same concept, but it's just drawn a little bit different. How tall is Yori? We've got a tree that casts a 20-foot shadow. Yori is over here casting a 5-foot shadow. How tall is Yori? Set up a proportion and solve it. Start by setting up a proportion. You have to, must, are required to show a proportion. If you do not show a proportion, I will not give you credit. So, we're going to start with our proportion. First, why don't we just use the two numbers that go with the tree? 25 and 20. 20 is the shadow, so it's on the bottom. I'm just going to keep all my shadows on the bottom. 25 feet and 20 feet. Carry your units across. All right. Now, looking over here, this is H is my height, and 5 is my shadow. Shadow is going to go on the bottom, so the top is H. How tall is Yori? Griffin? No. 6.25 feet. All right? Now, for all of you who guys, everybody who set this up right, got something else, quit guessing. All right? Figure it out. 25 times 5 divided by 20 is 6.25 feet. Now, let's convert this to inches. All right? 0.25 feet. 0.25 is 1/4. There's 12 inches in a foot, so I've got 1/4 times 12. To multiply, just go across, reduce before it's a lot. 12 and 4 is 1 and 3. that is going to be 3 inches. So he is 6 feet 3 inches tall.
Mr. Holsopple, I put the H under the 25, but I forgot to say that.
You put the H under the 25. Here's the thing with proportions. It is very hard to screw it up. All right? It is really hard to get them wrong. If you are careful, if you are intentional about where you put your numbers, if you have a reason, if you keep the stuff together that goes together, you're probably going to get it right. All right? If you keep the stuff together that goes together. How far is it from the hut to the gold coins? All right? So there is a hut right here. How far is it to the gold coins? Solve for x. Again, set up a proportion. There are only 4 things up there. 18, 15, x, and 12. As long as you keep stuff together for a reason, it's going to come out right. Okay. First, let's set up this proportion. All right. Now, I cannot when I put something in here, I cannot mess it up. I can put anything in there that I want. But as I'm looking at this, let's find the 2 numbers that go together in the same triangle, and let's use that as the first ratio. 18 over 15. Let's make that the first ratio. Carry your units across. All right. Now, I've got 2 more numbers over here. Once again, look at this. You see x and 15 are on the same line? You see that? X and 15 are on the same line. So, x and 15 have to be on the same line here. This is a 12. 15 times 12 divided by 18. How far is it to the gold coins, Bailey?
10 yards.
10 yards. It is 10 yards to the gold coins. Yes. Sure. That's fine. Listen, if you got the right answer, you're okay. All right? Because like I was saying, if you use a proportion and you are intentional about keeping numbers together that go together, all right, you're going to get it right. There are a ton of different ways that you can set these up. All right, we will save those. One more I want to show you. A car is 15 feet long. A model of the car is built using a scale of 1 inch to 3 feet. How long is the model? Okay, here's what we're doing. You're going to have a bunch of these on your homework today. Make sure you're paying attention. Set up a proportion. Okay? Here, we're not paying attention right now. Your scale is your first ratio. All right? As soon as you see that scale, put it in. 1 inch, 3 feet. Carry your units across. This should be easy now. It's 15 feet long. That's going to go with 15 feet. How long is the model? Amy? 5 inches. The model is 5 inches long. All right, go ahead and put your whiteboards away. Oh my God, I'm so news, good news. Bad news is, every single problem on your homework today is a word problem. Good news is, listen, proportion word problems are so easy. Every single, and listen to me again, every single problem today, you must show a proportion. If you do not show a proportion, I will not give you credit. Alright? I also said that on Friday. Last hour I had to give 3 people zeros in the grade book because they did not show me a proportion. Show me a proportion. Nope.